at one last example. Compounding interest again. Now this first one we're assume that $35,000 is invested into an account earning 4.2% annual interest for 3 years. In part A, we're going to look at compounding the interest semi-annually. That means a certain number of times per year. What does semi-annually specifically mean? Well, semi means two, kind of like a semicircle means 2 parts of a circle, half of a circle. So, n equals 2, semi-annually means twice a year. So, let's do our formula. The formula for a certain number of times per year is P times 1 plus R over N to the NT. Well, we already said what the principal was. The principal P is $35,000. That's what you're starting out with. So let's go ahead and plug that in. $35,000 times your 1 plus, that stays the same always. And then what goes on top of your fraction first is the interest rate, which was 4.2%, but we have to plug it in as a decimal, meaning divide by 100 or move the decimal place 2 places, which turns into 0.042. So 0.042 divided by n, which is the number of times per year you're going to get your interest, which we just said was semi-annual is 2, twice a year. Raised to the, notice, we've got another 2 on the outside as part of our exponent times the number of years we have. Our t is our number of years, which according to this one is, we're doing it for 3 years, so times 3. Our order of operations is going to tell us to start inside of our parentheses first. Well, what's inside of our parentheses that we actually want to start out with first is division comes first. So we're going to start out by taking our 0.42 divided by 2, and then whatever that is, we'll add our 1. Let's see what that is. Well, for that we will get, 1.021. We're not going to touch anything else. We'll leave the 35,000 out in front. If anything, we could simplify the exponent that's outside here, the 2 times 3, which that is just a 6. Now, order of operations says that I should do my exponent here first, which is the 1.021 to the 6th power, then multiply it by the 35,000 at the end. Exponents are before your multiplication. So let's see what happens when we do that. So when we take that 1.021 and raise it to the 6 and then multiply it by the 35,000, we end up with a final amount of $39,648.11. So that's your 35,000 you started out with, and the interest has already been added on automatically. That's your final amount of how much money you'd have in your account. That's your answer to part A. Now let's look at part B, which wanted us to do the same thing in the same problem, but compound the interest continuously. So if we're doing it continuously now, that's the other formula, the A equals PE to the RT. Well, the principal we've already said, the P is 35,000. The E is just a number, so we'll leave that as an E. The interest rate, our R, is the 4.2%, which as a decimal is 0.042. The time is however many years we're going to compound interest, which in this one was 3. So mathematically speaking, what I should be doing is simplifying this exponent first, doing the 0.042 times the 3 first. Well, if I go ahead and do that first, I'm going to leave the 35,000 and the E the way it is for right now. When I multiply the 0.042 and the 3, I'll get 0.126. So now I can do my exponent, e to the 0.126, and then multiply it times the 35,000 at the end. This gives us a total of $39,699.88 if we go ahead and round.